Coming to the outcome of today's session, today we will acquire the understanding of the logic behind BCD addition. Now in the session Introduction to Binary Codes, if you remember, we broadly classified the binary codes into two different categories, the alphanumeric codes and the numeric codes. Now in case of alphanumeric codes, if you observe the acronyms, ASCII stands for American Standard Code for Information Interchange. On the other hand, EBCDIC stands for Extended Binary Coded Decimal Interchange Code. So basically these two are Information Interchange Code, right? On the contrary, the numeric codes, if you remember the ones that we have learned so far, in case of weighted, the 8421, all the self-complementary codes, even the XS3 code, in all the cases, we actually tried to encode the decimal symbols 0 to 9 into their respective encodings, didn't we? So to be really honest, all the numeric codes are actually binary codes that encode decimals. However, over the time, due to its popularity, the 8421 code has acquired the name as BCD or binary coded decimal. So in this session, we are going to learn how addition works in case of 8421, which from now onwards we will also refer to as BCD codes. So let's begin with the BCD addition. Now for 8421 or BCD, this is the chart that we have acquired, right? Now let's observe the addition first, taking two patterns from here, say 0111, which in BCD is 7. Now let's take another pattern, say 0010, which in BCD is 2. Now if we perform the addition, observe what happens. 1 plus 0 is 1 and 1 plus 1 is 2 or 10. So we will have 0 as sum and 1 as carry. Now 1 plus 1 will again result in 10 and 10 plus 0 will give us 0 as sum and 1 as carry. Now 1 plus 0 will give us 1. Observe the pattern. It is the pattern of 9, and which is also correct in this case because 7 plus 2 results in 9. Now this is a simple addition. However, there are times if we add two different valid BCD patterns, we might end up obtaining an invalid one. Let me illustrate. Say we are going to add two different patterns, 0111, that is 7 again, and 0101, that is 5. So let's see what happens if we perform the addition. 1 plus 1 will give us 10, so 0 as sum and 1 as carry. Then again 1 plus 1 will also give us 10, and 10 plus 0 will give us 0 as sum and 1 as carry again. Now 1 plus 1 is 10 and 10 plus 1 is actually 11 or 3. So this time we are going to have 1 as sum and 1 as carry. Now again 1 plus 0 will eventually give us 1 only. Now observe, 7 plus 5 is supposed to give us 12. And this is the valid encoding of 12 if we only wanted to encode 12 as binary. However, in case of 8421 or BCD, this is an invalid pattern. Now why is so? Because in case of BCD or 8421, we actually have to encode all the different digits, don't we? So to bring this invalid BCD pattern into a valid one, we have to add the pattern 0110, that is 6, with this particular pattern. So let's do that. Now 0 plus 0 will give us 0, 0 plus 1 will give us 1. Now 1 plus 1 will give us 10, so we will have 0 as sum and the 1 carry will be added with this one. So 1 plus 1 will give us 10 again, and 10 plus 0 will give us 1 and 0. Now observe, this 0010 is actually 2 in case of BCD. Now if we append 3 more zeros to the left of 1, this is also 1 in case of BCD, right? So now the invalid pattern of 12 has become valid for BCD. Now the question is, why are we adding this specific pattern 6? Think about it. BCD's place values are 8, 4, 2 and 1. Now we know with 4 bits we actually can obtain 0 to 15, that is 16 different patterns, right? Now in case of BCD, we only are specifying that the patterns are valid till 9, that is 1001. Therefore, the derivable 6 more patterns, that is the 4-bit binaries of the numbers 10 to 15, are being discarded. So whenever any of those patterns are obtained, if we just add 6 to that, the result it will produce Although that will be a different value in binary, nonetheless, in terms of BCD, it will be valid. Just like here. This is the binary of 12. Now adding 6 to it, in terms of binary, we have acquired the pattern for 18. However, in terms of BCD, it is 12 only, because in BCD, we are to encode every symbol or digit of decimal, aren't we? Let me illustrate another BCD addition property. Say we are going to add this pattern 1001, which is 9 in case of BCD, with the pattern 1000, which is 8. So 1 plus 0 will give us 1. Now these two will give us zeros only. Finally, 1 plus 1 will give us 10. Now this is the binary of 17. However, this is invalid in terms of BCD. And how did we determine that? We did so because of the carry. So to bring this pattern into a valid BCD form, all we have to do is add the pattern 6 to it. So 1 plus 0 will give us 1. Now these two will give us 1s only. Finally, 0 plus 0 will give us 0 and 1 will just be 1. Now observe, these 4 least significant bits in BCD is 7, right? And if we append 3 more zeros as a prefix to this 1, we will obtain the valid BCD encoding for 1. Therefore, in case of BCD addition, there are 2 ways invalid BCD codes might be generated. One, if we actually obtain any of the 4-bit binaries of the decimal numbers 10 to 15. And the second way is if we obtain a carry. Now in both the cases, to obtain the valid BCD form, all we have to do is add the pattern 0110 or 6 to that invalid pattern, and eventually we will end up acquiring the valid BCD pattern. Now so far we have been observing the addition of single-digit decimals in terms of BCD. Let's now perform the addition of 789 and 123 in terms of BCD. Let's encode 789 first. So 7's BCD is 0111. Coming to 8, the BCD encoding is 1000. Now the encoding of 9 in BCD is 1001. Coming to 123, the encoding of 1 in BCD is 0001. For 2, it is 0010. And finally, for 3, it is 0011. Let's perform the addition now. Now, before moving ahead with the addition, let me tell you one thing. In case of BCD, the addition is sequential. Now, what do I mean by that? So what I mean is, at first we will have to add the least significant digits BCD representations. Now, if the answer is a valid BCD, then it's okay. Otherwise, we will have to fix that invalid BCD pattern. Then only we can move ahead to the next digits addition. So 1 plus 1 will give us 10, so 0 as sum and 1 as carry. Now 1 plus 0 is 1 and 1 plus 1 is again 10, so 0 as sum and 1 as carry. Now 1 plus 0 is 1, and here also 1 plus 0 will give us 1. Observe, this is an invalid BCD pattern, correct? So let's add the pattern of 6 to it. Now 0 plus 0 will give us 0, 0 plus 1 will give us 1. 1 plus 1 is 10, so 0 as sum and 1 as carry, which will be added with this one. So this will result in 10, and 10 plus 0 will give us 0 as sum. Now the question is, what about the carry? And the answer to that is that carry will be moved to this place, because these are the next digits. So 1 plus 0 will eventually give us 1. Then 0 plus 1 will be 1. 0 plus 0 will be 0, and 1 plus 0 will be 1. Now interestingly enough, this too is an invalid BCD pattern. So we will have to add the pattern of 6 to this also. So 1 plus 0 is 1. Now 1 plus 1 will produce 0 as sum and 1 as carry. So 0 plus 1 in here will give us 1, and 1 plus 1 will be 10, so 0 as sum and 1 as carry, which will be added with this one and which will eventually produce 10. Now 10 plus 0 will give us 0, and we know what to do with the carry. The carry will be placed in here. Now 1 plus 1 is 3, that is 1, 1, so we will have 1 as sum and 1 as carry. Now 1 plus 1 is 10. And 10 plus 0 will give 0 as sum and 1 as carry. Again, 1 plus 1 will produce 1 0, and 1 0 plus 0 will produce 0 as sum and 1 as carry, and finally we are going to get 1. Now this one is a valid BCD pattern, so we don't have to modify this anymore, so it will be placed just like this. Now 1001 is 9, 0001 is 1, and 0010 is actually 2. Observe, 789 plus 123 is actually 912. So this is how we carry out BCD additions for multiple digits. So in this session, we acquired the understanding of the logic behind BCD addition.